Hello class, welcome to Algebra Lesson 1-6, Solving Compound Inequalities. By the end of this lesson, you should be able to write and solve compound inequalities. So let's look at our first example, understand compound inequalities. So how can you use inequalities to describe sets of numbers graphed below? Okay, so inequalities, remember we've been talking about these, we started talking about these yesterday. Those are our greater than, or sorry, that's less than, greater than, less than or equal to, greater than or equal to. Okay, so we're going to focus on how can we use that information, those symbols, to represent what is graphed on that number line there. So if we look, we have kind of two arrows pointing out, right? We have one at the -3 and one at the 2. All right, so if I look and I focus just on this part for now, I know I'm going to have my variable is less than or equal to, because that circle's filled in, -3. Then if I look over here, I have x is greater than, not or equal to, because it's not filled in, and the number is 2. So my question to you is, can a number be less than -3 and greater than 2 at the same time? No. So what you're going to use is the word or. Whenever you have two graphs kind of happening at once and they can't happen like together at the same time, that's an or, okay? This, however, is a little different. So you can see I have something at -4. I have something at 1. So if I were to ask you to describe this, you would maybe say, it's greater than or equal to -4. So I'm going to use a variable. But if I follow that shaded line, it stops at 1. So it is also less than 1. So the way you can write that is -4x. Sorry, I keep saying so. My apologies. You can write that saying -4x is less than or equal to x is less than 1. This is one possible answer that you can use to write that compound inequality. Or some people feel more comfortable saying it is -4 is less than x, and we have x is less than 1. That's another appropriate answer. Some people, oops, that was a terrible box. Some people prefer to say x is greater than -4 and x is less than 1. Those are all correct answers. Everything that's boxed is an answer I would accept, okay? Now, I want you to go ahead and try to write the compound inequality for this graph. Good luck. Hopefully you said on the left side it is a -2, and I'm going to say that x is greater than -2, but x is also less than or equal to 5. So this is one possible answer, and I think I forgot to kind of mention on the last slide, whenever you have like something that has an endpoint on each side, that is called an and compound inequality. If I go back, you see how in this example the numbers kind of point out? Whenever you have that situation, that's called an or. And one way I remember that is if you were trying to row a boat, okay, so imagine a rowboat, you have an oar on each side. The oars have to stick out of the rowboat in order for the boat to move. So that's one way I help myself remember that or points out. And is when you have two endpoints and it's filled in between. Okay, so hopefully those couple of things will help you keep track of and versus or. Now, let's talk about just solving. So we have an or inequality here. We have 5x minus 7 is less than 13, or -4x plus 3 is greater than 11. You might look at this and say, I don't know how to start. There's two inequalities. Well, it's pretty cool because you solve them just the same way. it's like you're going to solve two different inequalities. So I'm going to start by adding 7 to both sides. So I have 5x is less than 20. Then I'm going to divide both sides by 5. So I'm left with x is less than 4 as one answer. And then I need to remember to write the word or. Okay, so I start by subtracting 3 from both sides. I'm left with negative 4x is greater than 8. Then I divide both sides by that negative 4. I'm left with x is less than, because I divided both sides by a negative. So I flip my sign, and 8 divided by negative 4 is negative 2. My two answers are x is less than 4 or x is less than negative 2. Okay, so now if I look at this, I'm going to write, let's see, this can be negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6. All right, so if I have x is less than 4, that's going to be an open circle at 4. And that's going to go on and on this direction, right? Then if I have x is less than negative 2, that would be an open circle going like this. So you can see sometimes people in rowboats get a little confused, or they have to make a really sharp turn. For whatever reason, pull the oar in from one side and have both of them sticking out on the other side. So or can also end up where you just have it pointing in one direction. Since the x is less than negative 2, do you see how this overlaps? Whenever you have that overlap, you don't actually need to draw in that overlap. You can just leave it like this as a final answer. Okay, so that can be your final answer for that problem. I'm just going to switch back to pen. All right, now I want you to try this problem on your own. Good luck. Okay, hopefully for this problem you ended up with a is greater than 0 or a is less than or equal to negative 5, and then your graph looked something like what I have down on the bottom. If not, please don't hesitate to ask for some help. I'm more than happy to help you. Let's look at example 3. So you can see that we have negative 12 is less than or equal to 7x plus 9 is less than 16. You have a couple of options here. You can either split up this inequality into two parts. You can do the green part first, and then you could do like the purple part second. And that would, if you were to split that up, you would split it up and it would look something like nothing that I've done so far. So let me show you what I mean. So I could split it up to be 7x plus 9 is less than 16. And then I could split and just do the green separately. So I could say negative 12 is less than or equal to 7x plus 9. And then I can just solve from there. So what I can do is say minus 9, that's negative 21, is less than 7x. Divide both sides by 7. Divide both sides by 7, that's a negative 3 is less than or equal to x. Since I divided by a positive 7, I don't have to flip that sign. And then if I move on to the one on the right hand side, I would again subtract 9, subtract 9. So now I have 7x is less than 7, or x is less than 1. Okay, so a number is greater than negative 3. That's what I get from the green. So I'm going to do a circle at negative 3 filled in because it's or equal to, and it is also less than 1. So I'm going to leave an open circle above that 1. So that's one way that you can solve the problem when it's written kind of all together like that. I know that can look a little intimidating. So if you want to split, by all means, go ahead and split it up into two inequalities to solve. If you want a slightly faster way, here is one other way that you could do this. So I'm actually going to use a color I have not used yet. So what you're going to do is instead of just moving it from one side to the other, what you're going to do is if I subtract 9 from the middle because I want 7x by itself, I have to subtract 9 from every side of those inequalities. So negative 12 minus 9 would be negative 21. We have is less than or equal to 7x is less than 16 minus 9 is 7. So again, I draw the two lines from my inequalities. I say, okay, I have to divide by 7, divide by 7, divide by 7 in order to get x by itself. And I am left with negative 21 minus 7 is, or not minus, divided by positive 7, my goodness, is negative 3. And then 7 divided by 7 is 1. And that is how you can write your answer. All right, well, question for you. Solve the compound inequality, then graph the solution. Good luck. Okay, hopefully for your answer you got x is greater than or equal to negative 9 and x is less than or equal to positive 9. And then your graph looked something like what I have there. All right, let's look at our last problem for our last example for today. Enrique plans a diet for his dog, River. River consumes between 510 and 540 calories each day. So we're going to say 510 and then 540. Okay, so we know that it's going to be either greater than or equal to that 510 or it's going to be less than that 540. Now, if River eats 1.5 servings of dog food, so 1.5 times 320 calories per serving, plus, so that's how much his food is. We have treats, and we know it's 15 times, I'm just going to do x to represent the treats. You can use a different variable, that's fine. So now, all I have to do is solve. So I'm going to simplify a little bit. I'm going to say 510 is less than or equal to 1.5 times 320 is 480. Plus 15x is less than or equal to 540. Now, if I subtract 540 from everywhere, so from the middle, so that way it cancels, from the left side, and then from the right side. So 510 minus 480 is 30, is less than or equal to 15x, is less than or equal to 60. Then again, to get x by itself, I need to divide by 15 on all of the sides. So then 30 divided by 15 is 2, and then 15x divided by 15 is just x. 60 divided by 15 is, not 40, sorry, 4. And it erased everything. That's fun. So using that information, go ahead and solve the last question on the lesson. Good luck. All right, hopefully for this problem, you ended up with 3 to 6 dog treats. If not, please be sure to reach out for some help. I'm more than happy to assist you. Here's the last slide for the day. If you would like to take a screenshot of the summary, the difference between and or, go for it. But I hope you guys have a great day.